The first step in conducting a hypothesis test is to understand what we want for our hypothesis mean and what is our alternative hypothesis. So suppose you are considering a hypothesis test for a population mean mu. Express the alternate hypothesis symbolically and identify the hypothesis test as two-tailed, left-tailed, or right-tailed. So the statement would go something like one of the following. You want to decide if the population mean is different from the hypothesis mean, greater than the hypothesis mean, is it less than the hypothesized mean, or at least or at most the hypothesis mean? What if we say it's equal to the hypothesis mean? How should we state our alternate? In all these cases, notice that our null hypothesis is the statement we're trying to test. And we represented it symbolically using H0 and state the mean is equal to some hypothesized number. We'll call that mu0. What is our alternative hypothesis? An alternative hypothesis is based on the statement that we're trying to test. We represent it using H1. And if we say, what if we want to decide if the population mean is different than the hypothesis mean? Well, this is a statement that requires us to say the alternative to the null hypothesis is that it just simply isn't equal to the hypothesized mean. So that's an alternative hypothesis going with set A. Right? How about if it's greater than the hypothesized mean? Well, if it's greater than the hypothesized mean, then our alternate hypothesis should go along with it, that the mean is actually greater than the hypothesized mean. So we'll circle that with the option B. And if it's less than the alternative hypothesis, the null hypothesis, our alternative, H1, will be that the population mean is less than the alternative mean, or less than the hypothesized mean. So what does that mean to us? We're assuming that if we say one-tail or two-tail, if we have a two-tailed test, then we're saying that we're testing our hypothesized mean against the alternate hypothesis so that the mean is actually not within the interval on the inside there. And so that our population mean is either somewhere out here or somewhere out here. And so we're going to actually want to know whether or not that's true. We use what's called a two-tailed test to do that. On the other hand, if we're saying that the alternative mean is that the mean is greater than the hypothesized mean, such as in option B, then we're talking about this right-tailed test. Right? That is, the actual mean is somewhat greater than what we stated, great enough to say that our hypothesized mean is incorrect. For C, when we say that the actual population mean we're only considering whether it would be less than the hypothesized mean, that is this left-tailed test. So this is going to be a right-tail test, is the way we phrase that. This is going to be a left-tail test. What about these other two statements, at least and at most? Well, if it's at least, that means that we're actually talking about what happens if the mean is greater than the hypothesized mean. So this is also going to be the case for D. Right? We're going to test if it's greater. If we say at most, then we're saying that we can consider the idea that the mean is actually less than the left tail. Option F, if it's equal to the hypothesized mean, means that we're actually talking about the same idea if it's equal to or not equal to. We really only have two hypotheses that we test. But in general, our default, unless we actually see statements like greater than, less than, at least, or at most, then we always are going to default to our two-tailed test and use it. But you have to be aware that in your reading, make sure that you see that we indicate greater than, less than, at least, or at most.